Substitution method is the best method for solving systems when one or both equations are solved for a variable, either x or y. So in this example written here, we can see that the second equation is solved for y. It says y equals negative 4x plus 24. So I'm going to take what y equals, and I'm going to plug it in place of the y in my top equation. So they tell me that y equals negative 4x plus 24, so I'm going to put that right here in place of y and substitute for it. So when we substitute for y, we'll have 2x minus 3 times, always put your substitutions in parentheses, negative 4x plus 24, because that's what y equaled. Next, we need to use the distributive property to distribute that negative 3 to the negative 4x and the 24. So we'll have 2x plus 12x minus 72 equals negative 2. And we're going to combine these like terms, so that we have 14x minus 72 equals negative 2. I'll add 72. So that 14x equals 70. I move everything up so that we have some more space to do our final step for solving for x, which is to divide by 14. We're going to get x equals 5. So we found the value of x. However, we're not done because the original problem involved two variables, x and y. So now that we found the value of x, we're going to bring it back and plug it into our y equals equation to determine the value of y. So y equals negative 4 times the x value, which we just found to be 5, plus 24. So y equals negative 20 plus 24, or y equals 4. What we've just found is the point of intersection for those two lines. So if we graph the two lines on the same graph grid, they would meet at the point 5, 4. So we always write our final answer as an ordered pair, and we'll tend to abbreviate point of intersection as POI. So when you see POI, just know that they're talking about the point of intersection. The one point that's on both of the original lines is the only x and y value that satisfied both equations. Let's take a look at another example. In this example, the top equation is solved for x. So I'm going to take what x equals, and I'm going to substitute it in place of the x in the other equation. So when I rewrite my bottom equation and I get to x, instead of the x, I'm going to put in parentheses what x equals, which is negative 4y plus 8. Then I'm going to continue copying the rest of the equation. Minus 5y equals 29. Now it's time for the distributive property. I need to distribute the 2 to the negative 4y and the 8. So negative 8y plus 16 minus 5y equals 29. When I combine these like terms, negative 8y take away 5y, that's negative 13y, plus the 16 equals 29. So now I'll subtract 16 from both sides to isolate my y term. So negative 13y equals 13. Divide by negative 13, y equals negative 1. So I'm like halfway there. I found the value of y, and I'm going to take that, plug it back in to find the value of x. Okay, so we're going to plug in our y value to our x equals equation. X equals negative 4 times negative 1 plus 8. So x equals 4 plus 8, or 12. So our point of intersection is 12, negative 1. It's the only xy pair that will satisfy both equations, and we can test that by plugging the 2 points into our second equation. And verifying that it works. So 24 plus 5. Does that give us 29? Yes, it does. It also works in the top equation that we use to solve for x. 12 equals 4 plus 8. So we can see the x and y values work in both equations, and you should always take time when you're done finding your point of intersection to check that and verify that yes, that xy value does work in both equations. If it doesn't, you've made a mistake, you haven't found the correct point of intersection. So let's recap the steps for the substitution method. Remember, this is the best choice when one or both of your equations are solved for variables, like the example shown below. This one is solved for y, so we could take what y equals, plug it in place of y, and solve for x, then plug that back in to find y. Again, this one's solved for y, so we could take that, put it in place of the y in the other equation, solve that equation then for x, plug it back in to find y. For this third one, it's solved for x, so we could take what x equals, plug it in place of the x, solve that equation for y, and then plug that back in to find x. Your first step is to determine what variable you want to substitute for and substitute. So you got to find the one that's solved for a letter. In this case, it's y, this one's y, this one's x. Then you're going to plug that in to the other equation in place of the correct letter. So if you're substituting for y, place the expression in place of y. If you're substituting for x, place the expression in place of the x. Your new equation should only have one variable. That's an important checkpoint. If it has two variables, stop. You've incorrectly substituted. So once you have your new equation with only x or only y, simplify and solve that equation for that variable. Once you find the value of your first variable, plug that value into one of the original equations and solve for the other variable. Remember that your final answer will always be written as a point of intersection. That's what POI stands for. So x comma y value. And that's the substitution method.